And so I'm going to start with some background slides on, you're recording, great. So I'm going to start on some background slides of what we're doing in IPDK. And then I'm going to go through just a couple slides on what we are doing with Kubernetes. And this is a two-part set of presentations. So, and today, if we don't have lots of questions, we may not take the full hour, but if we have lots of questions, we can take it. To talk about the separation between trying to tease out the infrastructure component of Kubernetes from all of the code needed to support the business logic or the tenant, that is using the Kubernetes networking. So we want to make that split because once we have split those two pieces out, it makes it easier to optimize that infrastructure and or move that infrastructure onto a IPU, DPU device separate from where the business logic is. That's background noise somewhere. That's where we'll go. So, this deck is on the website now. Just an introduction to what we're doing in IPDK. Effectively, we have this generic approach, and this is the approach that we're going to talk through today. Is really just step one, is to delineate, what is the business logic or what is supporting the business logic, getting it run, configured, plumbed in and out with IO, separating the logic of that, the code of that from, what we're calling the infrastructure, which is the hidden code to interconnect that business logic to the network, to storage, to different types of services that the infrastructure might be providing. And once you do that, it becomes a little bit easier to simplify some of the management of that infrastructure. Now that I've drawn a nice pretty box around it, I can start to potentially modify or evolve the management of that infrastructure box. And then the next meeting, which was going to be tomorrow, but we moved it to be 2 weeks from tomorrow. So 2 weeks in a day, we're going to talk about the third step, which is an optimization, where once you have that infrastructure drawn nicely in a box, then you can, at the bottom, look at a way to optimize that infrastructure. And our approach is compiler driven. So how to use a compiler to optimize it into P4 or eBPF or something like that, to be able to take advantage of an optimized data plane and software, or optimized hardware devices like in the picture. So that's our generic approach. We have a set of use cases on the website today. We have the start of what we'll call the IPDK container. This picture doesn't have all the bits and pieces that we're working on right now, but we've started to push out our patches for P4OBS, and we put those patches on the IPDK website. We are working on the integration of that with SPDK for storage infrastructure. And this set of meetings is talking about the work that we're doing for both Kubernetes and for Envoy service mesh. So the idea with this IPDK container, maybe I'll just pop up to this picture here, is that you could run that IPDK container or run IPDK components either in an environment where they're running inside of a host supporting guests through KVM, and that's the default configuration that we have on the website. So you can go and run it, and don't need any extra special components or hardware. Or you can run it with the exact same model on a physical device on the right. So that could be a switch, could be IPU, DPU, whatever. The difference is, instead of having these virtual orange smiley faces into each of the instances, there's a hardware hypervisor that's interconnecting each of these different hosts and hot plugging over PCI devices into each of the hosts. And there's a model in between where both the instance is virtual and your device, or your infrastructure device, is also virtual. And it's the same PCI orange smiley face in all three cases. And so on the website, there's a couple drawings, scribbles maybe, on how we are doing this for infrastructure as a service, and a couple of different recipes that are pretty basic at the moment on how to do this separation of, you've got my tenant logic on the left, and I've got either an IPU or vhost separating that tenant logic on the left with all of my infrastructure logic on the right. So there's some examples in IaaS for networking and storage for those types of scenarios. And I think on the website we have two different kinds of infrastructure offload or delineation, where in the networking case we show examples where the sort of the data plane runs through either the device or the optimized data plane, like an OVS DPDK, where it cuts right through this little gray box at the bottom, either hardware or optimized software, in the case of networking. And then in the case of storage, we are running the actual data plane through the container, where the data plane is sitting inside of software, inside the container, in this case, inside SPDK. So there's just two different examples of, sometimes the data plane is something that the IPDK container is controlling from beneath it, and other times it's or not beneath it or beside it or whatever, and other times it's the data plane is actually inside the container, inside software. And so we can have both of those models inside of when we go to Kubernetes. Lastly, on the I can find the right one on the website, we also have this example specific to the IPU, which is the idea that your IPU itself has virtual functions, and then we are able to handle virtual functions in the IPU where the control plane is entirely on the inside the IPU container. So this could be a DPU as well, which draw it as IPU. But the difference from KVM, from sort of the base case, is that there's just an extra nesting of configuration. Is that you need to be able to, when you go through the pathway of creating the port or creating the disk in this configuration, you also have to tell it the virtual function number. And that's because of this extra nesting, where I'm still doing my hot plug of devices in and out of the IPU to pop up these physical devices into the host server, but there's an extra layer of it's an additional trust zone. It's also another layer of software where this this host agent has to be matching up virtual functions inside the host server with emulated devices inside of VM. And so getting that mapping to work is the extra layer that we talk about on the website. And so this is also applicable inside of Kubernetes. If you are going to if you're going to do Kubernetes inside of a VM, then sort of all of this, where you have this agent on the host that talking to an agent inside the IPU container, all of this still applies because you do have to do this mapping of virtual function into the VM. It'd be the same if it was scalable IOV or whatnot, but you just in order to match up the sort of the hardware device with the emulated device in the VM, there needs to be some sort of matchmaker in there. And the reason why I brought this up, it's sort of orthogonal a little bit to what we do in Kubernetes, but the mechanism is the same. Is that we discovered a case where when we did that delineation, when we split the two pieces apart, in this case it wasn't quite so clean. We needed some amount of logic on the host to remain, so that we can spawn the VM, we can do sort of monitoring of the VM, and we can do this device matching between hardware devices and emulated devices. And that is going to happen more in Kubernetes, where sort of similarly in Kubernetes, you're going to have to go and spawn the container. You're going to have to go figure out, set up its network interface or its storage interface. And then you're going to have to map all that information back to what's running in the IPU container or IPDK container. And so we use the same model where we have these two agents, both from IPDK, that are going to have some gRPC layer where they're communicating across. And just like in this case, it's depending on your management model, it will depend on which direction the data flows. So we'll talk about a little bit about those decisions on data flow in the next slide. But in this case, the data can flow in either direction. You can imagine sort of, and this is my hands waving in the air, is you could imagine the configuration coming into the host server, telling the host virtualization agent like, spawn this VM and put this VM in this place and give it these services, and then go and connect up these 5 ports and 7 disks. And you could imagine the control being situated on the host side, where then this host virtualization agent goes, sends a message and says, I need 5 ports and 7 disks, and the platform manager responds and provides those. Or you could imagine it landing on the IPDK side, or the IPU container side, where it comes in and says, I need to spawn a VM with 5 disks and 7 ports. I think I got it backwards. And so then the control would originate from the right-hand side, go through that gRPC smiley face, and have the host virtualization just be secondary to all of that. And so you have both of those models in this picture. And so you'll end up with a similar situation with Kubernetes. And the reason why we wanted to separate out this part into its own presentation or discussion is that when you go to platform as a service, when you go to hosting containers, like I have in this picture over here, you have the same problem where you can imagine the management originating from the host, sort of leveraging existing management pathways that we're already using to set up everything for Kubernetes or for containers. Or you could imagine management pathways on the right-hand side leveraging existing pathways for someone doing something like a managed Kubernetes, or the same pathways that the SDN or the SDS are using to configure the infrastructure. You could imagine just expanding that out to also be able to land services and be able to interconnect and offer those services to containers on the host. So the way we have this constructed, and the reason why I went through all that setup on IaaS is we're sort of, for platform as a service, we're starting on top of that IaaS baseline, where we have the same container that's running OVS, that's running SPDK to do our storage protocol, that's going to offer these network devices and storage controllers. And so now we have these containers. So how do we, move some of the functionality that's here on the host server today for doing the containers sort of on top of the ports and the disks? How are we able to move that functionality out and into into the infrastructure? So we chose to start with Calico as our choice for Kubernetes networking. Felt like it was a popular choice and also pretty well optimized. It looks like it will lend itself nicely to offload. And so, what we want to do is effectively move the Calico out of this host server in this configuration and put it over inside the IPDK container. That was quick intro and setup. Any questions, or I'll pause here. See how we're going. Okay. Not going to discuss today, but we are been working on certain optimizations around the ways to be able to directly connect the containers to the infrastructure. Once you move, let's say you move your networking for your containers out of the host and into the IPU container, into the infrastructure on the right, there may be intervening software layers that may impact your overall scaling or performance. And so we're looking at two different mechanisms to be able to give you a direct connection, just like we have in infrastructure as a service, where when application sends a packet or sends a message, it sort of is directly plumbed into the infrastructure. And those two mechanisms are container dedicated queues, sort of like doing an IPVLAN, using hardware queues, like the hardware NIC queues, and local host sockets, which is just a socket-based sort of concept that uses the same hardware queues. We're not going to talk too much about that, but that will be a later topic, a later set of code patches that we're working on. All right, so this is what I was talking about earlier about the management interface. And going back to that approach, this is sort of that second stage in the approach, which is when I do this delineation, or after I do the delineation, all of a sudden, maybe I now have different options as to how I can do my management, or I can merge or maybe change the way some of the management of the system, both from the sort of the user's side and from the infrastructure side. I can make those changes if my environment can support it. And so the first model on the left and Ed Chen is on the call. Who these are his these pictures. Thank you, Ed. I think they're really good. Um, First model on the left is sort of a cartoon of sort of our base case. So you have your Kubernetes control plane, and some sort of this YAML spec is sort of the representation of our configuration of things that we're putting inside of our control plane to specify what services are being offered, where the endpoints are, things like that, to do our load balancing. And on the host node, we have a kubelet that will, create the set up the containers, put them in the right place on that particular host, and then we have kube proxy, which is going to set up all of the different virtual IP addresses and do the load balancing of all the microservices for that particular service that they're associated with. And then the CNI is going to be the interface to each of those containers, and it's also going to be the interface for setting up those services. And so there's lots of other pieces and components and things floating around, but so we pick out these key pieces in that baseline case to talk about how they move around when we start doing that delineation. And the first delineation that we've been working on so far has been this idea that we trust the platform well enough for the control plane of Kubernetes to stay the same, but the CNI, when there is some sort of configuration or change on the host, it will open up that gRPC link that we showed before. Maybe it's authenticated so that you know who you're talking to, and all the configuration that normally would have been on the host node. Probably should have drawn Calico in this picture in baseline 0. So now Calico is sitting in the infrastructure in the green. And now it's sending messages where, because they're no longer sort of resident on the same system, we're now sending RPC messages to Calico across. And all we've done is we've just drawn the boxes differently. We've just separated the two out. We haven't changed any code. We just if it was a simple thing of another process running in the same system being configured, I now have to send that over an RPC because I don't necessarily know that's even on the same system. And so this is sort of the simplest modification of the system, and it allows you to move all of Calico, potentially all of the data plane that Calico is running onto a new system. And so maybe that's a different instance of Linux. Maybe it's a specific version that is not using IP tables, but using something different. All of that optimization that can occur after the separation is our next meeting in 2 weeks. Another model, which is sort of like a managed Kubernetes, is to say that I'm going to move the Kubernetes control plane entirely into the infrastructure and have the infrastructure work it out, such that so if someone can let the new person in the lobby in. I'm going to have the kubelet on the host be driven by the infrastructure. So the infrastructure, just like in that earlier IaaS case, the control plane says I need to install a container on hosts 70 million. So I take that same gRPC connection that I have and I run it in the opposite direction. And I say, install this container with this image at this location, hook it up into this CNI, And then as services are discovered, that container that was instantiated now has access to those services. All of the service instantiation is happening directly into the infrastructure. And that's sort of I'm not going to set up Kubernetes myself. I would like someone to do it for me, and just give me these containers, put them wherever you want, and they need to have these services, and I'll do it for me. And so which is very convenient, but you lose a lot of control. And we sort of get the same desired end state where the Kubernetes and the Calico are now in the infrastructure, nicely separated from the host. And now we can go and optimize it, and and we've moved all of that logic off of the host completely. And then this final split mode is sort of our where we want IPDK to be sort of land as a final destination, because the 1 and the 2 are sort of degenerate sets of this third model, where my tenant or my end user can have their own Kubernetes control plane. They can place their own containers wherever they may like, or on the hosts that they bought or they own. But also there's an infrastructure control plane that can be placing services and handling the load balancing, handling the ACLs, handling all the security, so that those containers don't do anything bad. And also when you have, just like in case number 2, when you have an infrastructure running the Kubernetes control plane, the infrastructure can participate directly in some of these services. A simple example would be, let's say a container on the host node in either case 2 or case 3 says, compress this data using the compression service. And so that request goes out. The infrastructure may know of 100 different places that can do that compression for that container, but it may also have something resident inside of the infrastructure, inside the IPU, that does compression very efficiently. And so it can participate in that load balancing scheme to say, you know what, you want compression, I'm sitting right here a hop away from you, I'm going to compress it for you and send it right back. And so having an infrastructure owned and operated Kubernetes control plane introduces new ways for the IPU or the switch or the networking device that's participating in that infrastructure to be able to offload or make more efficient that service. So in 3, then the tenant gets to have a little bit more control than 2, and also gets to have the infrastructure handle more of the functionality of scaling out their application without having to set everything up. And it also introduces a new offload path to be able to make some of those services more efficient. These are the three models that we came up with. I bet there's more. So this meeting today is really just to kick off, sort of getting feedback. We've discussed this with others that we're working on in this area, to get feedback on, are these the right sets? There's always very constructive discussions around, all right, which box and arrow goes where. I do think that's really important to make sure that we get the right separation between. And then something that we want to run in the community around IPDK is what's the object model of these gRPCs that are running in between. So that's my next slide. But before I jump off of this one, any comments or questions? Someone shout back at me in the void, so I make sure that I'm not talking to myself.
We can hear you.
Okay, cool.
Yes. We can.
Awesome. Okay. So going to this RPC layer, going back to that previous picture. This is where we need some good definition that from the previous page that we drew all of our boxes and arrows correctly, and we said, okay, you stay where you are and don't change, but everything else like Calico moves on to the right side. I drew this picture as Calico P4 agent. It doesn't necessarily, this gRPC has nothing to do with P4 or nothing to do with the mechanism that we're going to use to optimize the platform later. It just so happens that our optimization step, I'm stealing the thunder of the next meeting, is to define the pipeline in P4. This communication is purely around something that I normally would have configured in the between the CNI and the infrastructure. Sometimes I can use the existing communication mechanisms, and other times I need to just sort of define this RPC to make sure that I have all the right information. And these patches that we're doing between the CNI here and the Calico, we hope to have them go into Kubernetes and not be hosted somewhere in IPDK land. So they should be something that's part of Kubernetes to make this an option to be able to do the separation. And I think we're on the path, and certainly folks who know this better are on the call as well. If people have questions, on the path to finding out the sort of the right way to do this in sort of the existing Kubernetes code base.
What exactly will this P4 agent configure or program?
For example, if you first needs to know which containers are on this host, so that depending on which direction it came from, to say, all right, well, I have this, I have a container here. If any of those containers are endpoints for a particular service, that needs to be communicated out. If they report themselves as being an endpoint for any service, and then using that information, then we can apply any sort of ACLs that need to happen on those containers. So just the most basic function of this communication pathway is to be able to say, hey, container, whatever, 1,000,001 is sitting on this host server and is sitting on this port. And so when you see that data, either inside the gray data plane at the bottom or any sort of software data planes inside the container, IPU container, know that that's coming from from that application or that service, and apply your ACLs accordingly.
Okay, it is just for application of ACLs, not routing or resolving, matting.
Could be for all those things. Yep, just a location service at a baseline, and all those things kind of build up from there. Sort of like, all right, well, now I know where that application is. Now I know where that container is. Now I might have, I might have configuration on the ACL. Might have a configuration on the routing, so that if something needs to go to or from that container, it can get there, all through the Calico side on the right.
Thanks.
Hi, this is Antu. I have a quick question.
Yeah.
More general level. Why Calico? Or is Calico the first implementation that you're using versus some other CNI?
That's a great question. I would say it was a little bit. So how we chose OVS, it felt like a natural or sort of obvious starting point.
Yeah, makes sense.
And that made sense, but for Kubernetes, it was not clear, and we felt like we had like 10 different choices, and so we went with Calico. We felt that it had the most traction, and we also are maybe we have too many networking folks, and we liked that it was using routing, and it felt very networking centric, and it had already had some work done in the past with VPP in terms of providing alternative data planes. So for those reasons, we chose Calico, like you said, first. Maybe we may find another type of Kubernetes networking solution that we could also apply this to, but we had to pick one.
Okay. Because off the top of my head, I came from VMware, Entria with OVS backing. Might be another candidate.
Agreed. Yep. And we looked at Entria as well. In fact, we may have started with Entria a little bit. Also a great option. Yep.
Okay. Thank you.
Yeah. So next steps on this is putting these slides will be online. We'll start a Slack channel on this as we do some more of the development, and then hopefully soon we'll be able to seed the development with some code patches, and wanted to start this discussion early because of this sort of defining question of like, how do you draw the boxes, and did you get the right box on the left or the right? Because that will change potentially the RPC, either make your life harder or easier depending on the type of communication between the yellow and the green. And we want to get feedback that this split model is sort of the right goal, or too complicated. Just want to stick with number one and keep things simple. Or if we're all trying to get to a managed Kubernetes model, and two is also sufficient. So want to put that out there to get feedback as we do a little development, and when IPDK's CI infrastructure gets set up, we also would then have the option to move the development to be an open source development, as opposed to us sort of dropping code along the way. So we do hope to get that up and running soon. And that CI infrastructure is just at the moment sort of a carbon copy of the SBDK infrastructure of having patches posted and then approved, automatically checked, and then the core maintainers will upvote them to be committed. So I think we're we're still a little ways away to having that set up, but that opens up a lot more collaboration options, because then the code is just there, and it might be terrible, but everyone can see it, and you can see the patches and all the history on the GitHub. So that's all I had for today. So happy to take questions on any of the topics that we touched on, or even just generic IPDK questions, since we're pretty new. Don't even have all of our functions up yet, but we'll keep doing these topics and see if we get good attendance and people pulling down the video over time, and starting to get some structure, especially when we get our move our code development onto the GitHub officially, when we get our Garrett up.
Hey Dan, I just posted the EuroP4 link also if people are interested in the demo.
Thank you. Anjali, do you want to give a little intro onto that?
Yeah, so we started like a year back, and we did a couple of P4 conference presentations on the similar topic, and the recent one was in December. So Nupur, myself, and Vinod from Intel, who have been trying to put all the software, hardware, pieces together. So this was a small demo of load balancer offloaded onto the IPU. So feel free to watch that, and then after 2 weeks, the talk that we are having will go in a lot more detail and field questions and things like that. Yeah.
Thank you. Yeah, that's good. That's good. And I'll try to get that. Maybe I'll make another announcement on the IPDK to put that EuroP4 presentation out there. People can look at it before the meeting in 2 weeks. So I'll try to put that somewhere prominently on the website and get that collateral at least linked in. Great.
Thanks,
So
Dan.
I will stop the recording and